Hello and welcome back. Right now we're going to be talking about phase change. And what is a phase? Well, we have pure substances and a phase is defined by the intermolecular forces. Three phases are relevant for this course. The first one is going to be solid, molecules that have three-dimensional arrangements and they keep in fixed positions. We also have what we call the liquid, which molecules may rotate and displace freely, but are not as free as the last phase, which is a gas. There is no molecular order, molecules move randomly. The liquid phase is what we call the compressed or subcooled liquid, and is that when we're not going to be vaporizing. It receives heat and lightly expands when temperature rises. Saturated liquid is when the liquid reaches the boiling temperature, and this is about to vaporize. So remember that this boiling temperature in this case is called the bubble point. In the gas phase, the saturated vapor is the gas that is about to condense and is in its condensation point, which is the same as the boiling point at a constant pressure. And this condensation point here is called the dew point, remember that. Superheated vapor is a gas that is not about to condensate, but it has high temperature as the condensation point. In the boiling process, when a liquid passes to a gas phase, part of the liquid is evaporating and part is already steam. This is called a liquid vapor mixture. This liquid vapor mixture it's at the same temperature during the whole process, although the energy is being gained. The temperature is called saturation temperature and is the same temperature during the whole process, right? And this saturation temperature and pressure, it depends. The saturation temperature, boiling or bubble point or dew point, depends on the substance, but also on the pressure. When the pressure is 1 atmosphere, the saturation temperature of water is 100 degrees Celsius. If the pressure decreases, then the saturation temperature decreases as well. At a certain temperature, the pressure in order for the phase change is defined as the saturation or vapor pressure. Here we have diagrams which state what is the phase change process. So we have a compressed liquid, and then we need to input in this temperature, there is going to be this saturation mixture. Here, this is what we call, remember, the saturated liquid. Here is the mixture. Here is the saturated vapor. And then we have the superheated vapor. In order to perform this transition, we're going to have this amount of heat that is going to be changing with temperature. Then we have the enthalpy of fusion to pass from solid to liquid. Then we have this amount of heat changing temperature, and this is going to be the latent heat of vaporization. So what we call the sensible heat is the energy that is absorbed during a constant phase, and it's increasing temperature. Remember, delta H is going to be equal to integral of Cp dt, but in the latent heat is energy absorbed during phase change, and the temperature remains constant. Here is seen at property diagrams, and a lot of diagrams exist. Properties can be found in these diagrams, and one important point is the critical point, the point where the saturated liquid and saturated vapor coexist. There is no need of the vaporization latent heat. Here is an example of this diagram of temperature and volume. Here you can see that at constant, these are lines of constant pressure. At constant temperature, you have this constant pressure. This is the saturated liquid. This is the saturated vapor. Here is the mixture. And at the triple point is where they coexist, this saturated liquid and saturated vapor. Here's another example. The temperature volume is exactly the same diagram. Here you have the saturated liquid line, the critical point, and the saturated vapor line. And once again, this is sensible heat, and this is going to be latent heat because it's at constant pressure. This is the saturated liquid vapor region and constant temperature as well. Here is a PV diagram where these lines are the temperature lines, and once again you can see these regions. And if you include solids, an important state is going to be the triple point. At constant volume is the point of pressure and temperature where the substance coexists in the three phases. If the volume is not constant, it is seen as a line, not as a point. So here you have the triple point, and once again, you have here the solid, the vapor, and here is the sublimation line. Here you have the melting line. This is a melting line when substance expands on freezing, just like water. And here is the vaporization line. You have liquid here, you have vapor here, you have the critical point, here you have the triple point. But if instead of having a pressure and temperature diagram, you have a pressure volume diagram, you can see the triple line. And here you have, once again, all the phases. Here is another diagram of pressure volume, where you can see, once again, all the phases with this triple line and the critical point. In order to get the latent heat, well, you can have, let's say, here in these tables, you have the critical temperature, the critical pressure, you have the specific gravity, and remember here, or see, you have here the melting temperature and the heat of fusion at this melting temperature. This is the normal point at 1 atmosphere. Here is the boiling point, also at 1 atmosphere, and then you have here the amount of heat in order to do the vaporization. This is the latent heat of vaporization. Sometimes you have to change the pressure. So if you have to change the pressure, you can estimate the delta H of vapor at a temperature which is in the average of T1 and T2, two temperatures, if you know the vapor pressure at these temperatures. And remember, you can actually get these vapor pressures with Antoine equation, and all these temperatures has to be in Kelvin. So here you have the delta H at an average of temperature equals R, the constant, T1 times T2 over T2 minus T1, natural logarithm of this vapor pressures ratio, which you can estimate with Antoine. You can also estimate with the Watson correlation at the temperature, if you know the critical properties, critical temperature, the latent heat at, let's say, a value of T1, which can be the normal one in these tables, and you just have to do this delta V times Tc minus T2 over Tc minus T1 elevated to a power of 0.38. With this, you can get this latent heat of vaporization, which is the amount of heat that you need, remember, in order to change phase. And at this process, pressure and temperature remains constant. Thank you very much. This is all about this video.